We need to alter the things. Suppose think like this: if this carbon having double bond, it's already balanced, so we can't fix this. So that's why we are removing it up. So it is fixed. So now it's okay. So this is not satisfied. So that's why we are satisfied when you are transferring the double bond from here to here. But this carbon and this carbon, if it's continuous, it will be of 5. So again, this we need to change. So like that, for the satisfaction of the valency of the carbon, we are going to change the position of the double bond. That is the only thing we need to do. Nothing logic, nothing much is there. Anybody got answer? Sujit Ali, Sujit CS, Sujan, Sneha, Yashaswini, Mamata, Martin, Hitesh. Only Meghana is there in my class. Gokul, Nikhil. Nikhil also keep quiet nowadays. See, first I'll, for your understanding, I'll write from this end to this end. Okay. CH, CN, single bond, CH2. So there should be N. Then here again CH2, CH, double bond, CH, CH2. So this end is one more is joining. 1, 2, 3 plus 4 done. 1, 2, 3, 4 done. 1, 2, 3, 4 done. 1, 2, 3 with hydrogen 4 done. Hydrogen 1, 2, 3, 4 done. 1, 2, 3, 4 done. So like that. Okay. This is the structure of your Guna N, nitrile rubber. Okay. So because of the resistance towards gasoline, so it having an resistance towards gasoline, it's used as an lubricant, lubrication oil or lubricating agent. And it can be used for organic solvent. It's used as an organic solvent for the separation method. You have filtration methods and separation methods. So for that and all, we can use this. Okay, fine. Next, so till here we are done with copolymerization. So now we have molecular masses of polymers. Molecular masses of polymers. Okay. Gasoline is a substance which used to which will create bubble in the leather format. It's okay, Nikhil. Meghana, the gasoline is a component that used to make a bubbling in the formation of your leather or textiles ಅಲ್ಲಿ bubble nature form ಮಾಡುತ್ತೆ. So that is called as gasoline formations. So we need to break it up. Then ನಾನು correct ಆಗಿ ಎಲ್ಲಿ ಫಾರ್ಮ್ಯಾಟ್ ಆಗುತ್ತೆ ಅದನ್ನ I'll tell you in tomorrow's class. Okay, gasoline I'll explain it in tomorrow's class. So okay, molecular masses of polymers. Molecular masses of polymers. So now, if the lengthiness of the polymer, yesterday, I think Gokul asked me like, ma'am, till how many atoms we need to add to become a monomer into a polymer? You are seeing my screen in blur, right? Just a minute, I'll do it. Okay, is it clear now? So molecular masses of polymers. It means to say, so how much length we need to take up that monomeric units. Okay, how much length, or as the Gokul asked me yesterday, how many number of monomer we need to add to become an polymer. So to calculate the mass of it, how we can do. Okay. So for numbering, for how much number we need to add or how much number we need to calculate, the molar mass, the molecular mass also called it as molar mass. So we have one formula called, so you just write the monomeric unit as N1, N2, N3 and so on. And the masses of it seems to be M1, M2 and M3. Okay, so the number of monomer is represented in N1, N2, N3 and the masses of it is represented in terms of M1, M2, M3. So we need to calculate the average molar mass. So average molar mass is equal to N1, M1 plus N2, M2 plus N3, M3 and it's so on. So we can't write each and everything, right? So it's continuous divided by number. This is average formula, right? N1 plus N2 by plus, sorry. So it's continuous. So what you will get the formula at the climax. So it's of sigma Ni means integeric number by sigma Ni. This is your formula to calculate the average molecular mass of your polymer. Average molecular mass. Number of average. So how many number you have? So suppose the monopolymeric unit, whether it's contain 10 or whether it's contain 12, how many monomeric units is contained? So that represent by this formula. Okay. So now weight average. So we already calculated the number of average. So now we need to calculate the weight of average. Weight of average means what is the mass, molar mass of the component. So that mass or weight is represented as m1, small m, small m1, small m2 and small m3. As usual, the molar is represented in the capital M, that is m1, m2 and m3. So same formula we need to apply what we applied for the number average molecular mass. M weight, so we are representing it weight, W for weight. So m1 plus small m2 capital M2, okay, plus small m3 capital M3 divided by small m1 plus small m2 plus small m3. So same, it will become the same thing. The sigma small mi capital Mi divided by sigma small mi. This is the formula for number average molecular mass and weight average molecular mass. Okay. Then biodegradable polymers. So, and I didn't send your notes, right? Polymers notes. Did I send it? PDF notes of polymer. Nikana, did I send? Polymers notes. What do you mean by biodegradable? Can anyone just explain what do you mean by biodegradable? I think you might have much more familiar with this because of it's a common word. We usually make use of this word. Naturally occurring. Uh, Naturally occurring, true, but the definition for biodegradable is somewhat changing there. Just split up the word biodegradable. Try for the other times. Gokul. Yes, it's get yes, Yashaswini, capable of being decomposed in microorganisms. Super answer. It's get degrades easily in the nature, right? Substance which can be decomposed within a period of time. Yes, Kukul. That can be also the definition. Good. Yes. So I got to know that rest of the people are sleeping. Hmm? So bio students would have know much more familiar about this. So biodegradable means, as the word says, bio means living. Degradable means decompose. Okay, decompose. So what are the polymeric units that which having and capable of decompose in your living area? It means to say if something on sand or soil or in water, it should be dissolve it, and the content of those component what you are throwing or disposing, that should mingle with the soil or water or air. That is called biodegradable. So for example, we are generating carbon dioxide, right? So the carbon dioxide we are living out of the body, that is produced due to the metabolic activities. So that produced carbon dioxide is combining with your atmosphere. That's why we can't recognize whether we are releasing carbon dioxide or that carbon dioxide, whether it is utilizes or not. We can't see it, or it's not showing as it is a waste dust. So we need to make some other work from this. So we don't want to think like that because it will mingle with your air. Like that, you will usually throw the vegetable chops, peel one, or some seeds present inside, so that all components will dump into a plant suck or in a big pit. So upon the top they'll put soil. So if they dug it, they didn't recognize an vegetable or leafy things or anything else. So that will combine with your soil and it will give nutritive component for the soil. That is called biodegradable. So the polymers which doesn't harmful for the living kind, which doesn't make any disturbance for your living nature, that may be in soil, that may be in water, that may be in air. If it doesn't affect on it, that is called biodegradable. It should combine or it should convert into a simplet form and it should decompose with your bacteria. Either it may be in bacteria or it may be anything, but it should be combined with your natural resources and it doesn't make harmful to it. That is called biodegradable. But usually what you all stated, that is true. We used to define it like it's decomposed by your bacteria present in soil. So that we are usually giving the definition for biodegradables. So let us see what are the biodegradables that is present in polymers. Okay, first one, it's your poly beta hydroxy butyrate co beta hydroxy valerate. So lengthiest, right? So PHBV, we usually call it as PHBV, poly beta hydroxy butyrate co beta hydroxy valerate. This is called, they usually ask you like write any two biodegradable polymers. Okay, they usually ask you like this. And this is made from the two components. So this is as usual copolymer. So this is made up of beta hydroxy butyric acid, beta hydroxy butyric acid, and beta hydroxy valeric acid. So it's a composition of two things. That one is a beta hydroxy butyric acid and valeric acid. Okay. Let us write the structure of beta hydroxy butyric acid. This is called we usually call beta hydroxy butyric acid in terms of IUPAC name, that is 3-hydroxy butanoic acid. So you should know both the names, because when they used to tell you to write the structure, they used to represent by the IUPAC nomenclature, not in the common name. This is called 3-hydroxy, 1, 2, 3, called 3-hydroxy buta, 1, 2, 3, 4 carbon. Yes, of course, it's buta. Oic acid means it contains COH group. That's why it's oic acid. Okay, got it? So 3-hydroxy butanoic acid. Plus beta hydroxy valeric acid is also called as 3-hydroxy pentanoic acid. And write the structure. Plus CH, CH2, CH3, CH2, COOH. This is called 3-hydroxy pentanoic acid. You could have asked me, ma'am, how can we recognize, how can we identify whether it is common name or it is IUPAC name? Yes, that we have one hint called, if you are naming penta, buta like that, so that is IUPAC name, that is the first hint. And we won't use alpha, beta, gamma in your IUPAC nomenclature. We usually use it in numberings. So if you are using the number, so that is IUPAC nomenclature. If you are using alpha, beta, gamma, delta, that's also represent the position of the functional group only, and the numbering of carbon or functional group is also representing the position of the functional group. But here, uh, the light thing here, we usually code it in alpha, beta, gamma, delta in common names, and 1, 2, 3, 4 in our IUPAC nomenclature. Okay. So you could have easily recognized of it. So when these two are combined in n number, we'll get the product called Just link it up, H here, OH here, H here, OH here. That's it. Okay, do it fast. Let us see who will write fast. Done? Finished? So we usually use it for capsule preparations. So in your medicines, they inject some medicine drug inside and they used to make it a plastic polythene, right? So we usually think it like whenever childhood days, I used to think it like why they were giving plastic, it will harmful for our body, right? So what I'm thinking like we need to remove it and we need to take that because of the bitterness. They won't give you the tablet as in the format of capsules. Sorry, in the format of the solid things. That's why they'll make a powder of it and they'll put it inside the capsule. That capsule cover is made up of your BHPV. PHBV. Okay. So next, second one. It's a biodegradable, environmental biodegradable. Next, second one is nylon 2, nylon 6. Okay. We have two more. Please write it fast. At least today we need to finish it off. So this is of course copolymer and it's a composition of glycine and amino caproic acid. Composition of glycine and caproic acid. NH2, CH2, this is structure of your glycine, COOH. This glycine is an amino acid. You might have known this. This is glycine. Glycine, you should write NN for your monomeric units. So this is your amino caproic acid. So when these two are combined, just join these two links and remove water molecule. H here, OH here, H here, OH here, same. CO instead of that, you can write like this also. This structure of your nylon 2, nylon 6, N2, N6. We usually call it as N2, N6. Next, polyglycolic acid, PGA. So this you obtained from glycolic acid. Glycolic acid. It is like this structure. So no two units, only single monomeric unit. So this is not a copolymer. This is an polymerization. So if you are getting two or more functional group, that is copolymer. If you are getting only one functional group, that is called polymerize. So when you are repeatedly adding your glycolic acid, you will get polyglycolic acid. This is called polyglycolic acid plus NH2. Next, polylactic acid, that is PAL. Sorry, PLA. So this is also polymerization reaction. This is not copolymerization reaction. So your polyglycolic acid and polylactic acid or polymerization reaction, you'll get it from lactic acid. So you should write this. I'll write the monomer, and you should write the polymer. So this is lactic acid. Get the product from this. Create it. Same, just repeating units of it, you will get poly. Yes, good. Just remove HOH here. That's it. This is polylactic acid. So if you are mix PGA, glycolic acid and polylactic acid in the ratio of 90:10, it means to say for 90 ml of polyglycolic acid and 10 ml of polylactic acid, if you are adding, this composition will be used as an adsorbable switches to close internal and external wounds. They usually used to give the white color powder to curing of your wound, right? So that's the composition of polyglycolic acid and polylactic acid. So this is the last topic of your polymers. I'll send up the notes for this, and from tomorrow we are going to take up with a new lesson. Okay, sure, that's right. So, okay, any doubt you can ask me. The session will end in 1 minute. This is your last topic of polymer. So in Meghana, I'll explain it in tomorrow's class. What you ask about the question of gas stolen. I'll tell you tomorrow. Yes, Meghana, I got it. It's a petroleum product. Gastrolin is an petroleum. We'll get it from the extraction of the petroleum in our seashores. So that present in aliphatic and aromatic hydrocarbons. So we usually combine that to increase the temperature of carbon. So gastrolin is a petroleum product. It is occur in the aliphatic and aromatic compound. The composition we use to make it to increase the boiling temperature of your carbon from C4 to C12. That is what they were given here. Okay.